So today we're doing min stack. So we are given a bunch of functions, and we have to incorporate a stack that can perform the operation get min in O of one time. All of these operations have to run in O of one time. So what we're going to do for this is we're going to utilize the use of two arrays that are going to act as our stacks. So let's do black. It's a bit more easy to see. So we're going to have our, let's say that's our main array, and this is our min array. Stack and min. So main stack and our min stack. So let's push some numbers and see how this is going to operate. So let's say we initially push the number 2. So we add the number 2 here to our min stack, since it's our first element. And then let's say that we add an element 3. Great. Since 3 is more than 2, what we're going to do here is just add 2. So when we incorporate it like this, when we eventually remove 3, so we pop it from the stack, we can pop this one from the stack, but 2's under it because there is a 2 under. So if we have here 4, then we just add 2 again, because we have 2 all the way down here. So that way we can just keep track. And let's go back a bit. Let's say we add 1. Now we add 1 to the stack. So let's say we pop this. That means we pop both from the stack. So whatever we do to the main stack, we're going to do to the second stack as well. So, and then now the min is 2, because there lies a 2 in the main stack. So great, let's go ahead and start coding that. So we're going to have our 2 stacks. I don't think these are indented properly. They aren't. Oh, there we go. So we're going to have an integer because it's an integer stack. And we're going to have 2 of them. Great. Now we're going to have some size variables. It just saves us calling, whoops. It saves us calling, say, like stack.size -1 when we want the last element. Integer min size equals 0. Awesome. So, let's start off with our push. So as you know, push in a stack, you just pop it on top of the stack. In array terms, you just pop it to the end of the stack. So, we're just going to straight away do that. We're just going to add the val. So it's easy to add to that stack, but it gets a little more tricky with the min stack, because we have to do some condition checks. So if size is more than 0, that means there's more than one element in the array. So we can do some operations to see if we need to overwrite our min. So to see if we need to inject a new element. And if it's not less than it, then we just push this one again. Push the last lowest integer. But if that's not the case, and it's the first, if it's less than 0, that means it's the first element. So our else statement is just going to be min.add val min size plus plus. Awesome. And at the bottom here we can do size plus plus because we added to our main stack. So if it's our first element, we do this one, and if it's not, we go to here. So our condition is going to be if size is greater than 0, and I guess we don't really need that, but oh well. We can probably remove that. If size is greater than 0, and the value that we're given here, our parameter, is less than min.get min size minus 1. Now what this is the top element of our stack. Oops. So if we move them, it's min.get min.size minus 1, which is our top element. So if the value we're given is less than that, then we're going to push that to the stack. Min.add val. So now that's on top of the stack. Min size plus plus. Else if the array isn't empty, but the value we're given is more than the top of the stack, I guess it would just be else. So if the value isn't smaller, then we're simply just going to re-add the top element, which is min.get min size minus 1. Awesome. Update our size variable. Great. Just seeing if I can add a comment here to make it a bit easier to read or understand. So this one is pushing to min stack. Amazing. And we add size plus plus down here so it doesn't mess up with this. Because on the first element, if we put it up here, it'll break this code. Because it'll try to get from index minus 1 in that case. Okay, great. So there's our push. And now our pop. So when we pop, remember we want to pop from both stacks. So stack.remove size minus 1. Min.remove min size minus 1. Now, dot remove is actually O of n, but since it's the last element in an array, it doesn't have to shift anything. So if you imagine it like this, if we wanted to remove 3 from this array, I would need to shift this last element forward. But since we're just removing the last element, nothing changes here. So it's just O of 1, which is great. So that's the beauty of a stack. Ooh. So O of 1, as it's the last element. No shift. Ooh. No shifts. Cool. And once we've done that, we have to do our sizes. In size minus minus. And now we've pretty much done the chunk of absolutely everything here. So when we do top and stuff, we can simply just return the top. Dot get size minus 1. So that gets the top element. And min, we've already done the bulk of our min. We've done all the work for setting up the correct return in the insert function. So here we can simply do min.get min size minus 1. Yep. Great. See if there's any tweaks that we need to make. Awesome. Brilliant. 5 milliseconds beats 99%. 90%. Awesome. Cheers, guys.